Hello, my name is Alan Folmsby, and today I'm going to be talking about how a nucleus is connected to a molecule. So, for example, in hydrogen you have one proton with an electron, and that's like just an ion. But then the molecule is two of these, two protons and two electrons. And I'm going to show how they got bonded together using the 8-dimensional physics that I've mentioned before. So I'm going to tell you about that in a very organized way. And for example, I have these PowerPoint slides that give you some of the overview of what you'll be seeing of the new geometric display of an atom using Blender, using sketches, and using a hand-built model, using styrofoam spheres for nitrogen or boron. And I'm going to draw some new sketches for you. And so let me show you some of the text here. All right, now I'm going to just bring up the beginning PowerPoint slide. A molecule from several nuclei. And this is emphasizing flux, which is common in physics. And also I'll be talking about the concept of the itinerant proton currents. And atoms, of course, and molecules are made using a wave function. In standard science, the wave function is, you already know what the wave function is in standard science, so I'm not going to actually repeat that. And for the future science, units of measure are back in fashion. Now, the Weber is a kind of flux. It's lines of flux per second. And Tesla is Webers per square meter. And then a line of flux is using dimensions 5, 6, and 7 in the new accounting system that I've proposed. For example, dimension number 6 is a length of a velocity, hx. So in other words, hx is one dimension, and it has units of velocity. And in an atom, there's a length of this, a certain number of meters of this velocity. And that is part of a bond. And I have a hydrogen molecule sketch that I should just draw for you right away. And I'm going to just move the camera around for a second. And while it is, I'm going to entertain you with something else.
Hello, it's Alan Folmsby here in my front yard. This is where I discovered the shape of the iron nucleus.
All right, so I'm going to bring the camera around, and as I've been saying in previous lectures, there's a sketch that can be drawn of what is a proton paired with an electron compared to the whole universe being paired with that proton for gravity. So this is similar to pictures I've already showed you before, in which the red in the middle here is the proton over there, and then it's paired with an electron to the right there, also with red. And there's only two space dimensions connecting the two, and one time-like dimension going the other way. And now in the gravity continuum, you've got these three dimensions in black coming down, and those are the three space dimensions, x, y, and z, and then time comes out radially away from the proton at the speed c. And then there's a mirror at the center of the proton that's reflecting this gravity, producing these electromagnetic dimensions here in the going to the electron and to the neutron. So this is just one kind of picture that I've been putting together. I've already showed you this kind of thing, but also I'm also trying to show you that there's more geometric displays that are possible for people to comprehend a little better about the geometries. So here's a Blender file where I've got the proton in the middle here. It has the 3 electric space dimensions coming out and 1 time-like dimension going in. So I've shown that as protrusions of 3 dimensions and an opening for a 4th dimension to come in to the proton. Now on the left is the neutron, which just has 1 opening, so that the z direction of the electric z will be connecting these 2 baryons. And on the far right I have this electron symbol, and it has the 1 large time-like dimension coming out of it going to the proton, and then 2 openings on it to take in 2 space-like dimensions from the proton here. So I'm able to, using Blender, I can just rotate this stuff around for you here. All right, let the rotation begin. Let's see, push some buttons, A and RR. Let's see what happens. Oh, look, it's all rotating. There's the electron. All right, it's successfully rotating. If I can just get away from the screen here for a minute on this live YouTube streaming facility. This is a half-hour show today on molecules from nuclei. So imagine in the future, like next week, I'm going to have a more highly developed Blender model for you, and connecting this proton-electron pair will be 2 membranes that are spinning opposite directions. So in other words, there will be a dimension here called HX going to the electron, and there'll be a dimension over here called HY curving around to the electron, and then flowing the opposite direction is the sum of those 2 velocity values coming out as the TH going from the electron back to the proton, making it the complete loop. And it's a circuit in which there's 2 spins. So the spin would be going, of course, this way, counterclockwise at the bottom. And the membrane at the top will be going clockwise. It comes out of the proton and it returns from the electron, making this clockwise spin for each electron. And you can observe 1 spin at a time. Now the neutron over here then is not involved with that flow, but there's more, I propose there's more variability than in gravity, so that even though gravity is constant, these 4 other dimensions, 5, 6, 7, 8, are able to shift lengths of velocities around. Now I'm going to show you a little handmade model I'm going to try for you. As you can see, I'm just preparing a lot of these models and things for you to look at. I'm going to point the camera down now closer. Oh, that's much better, yes. That's the carbon nucleus mock-up there. And it has a little cube at the center. It's hard to see, but let me just bring in the cube alone. So as you can see, the cube has 8 brown and white nucleons. There's 2 of these white protons and 6 brown neutrons. 2 white protons, 6 brown neutrons. So that's 8. 2-layer cube. And there's also 3-layer cubes available. But for today, for simplicity, I just wanted to point out that there could be a correspondence between these 2 protons in the middle and the 2 s electrons in light elements. For example, if you put some more protons around this, you get the carbon. Let's look at carbon for a minute here. There, we're pushing out the little cube, and we're bringing in the carbon that has a cube in the same orientation. So there you can easily see carbon has that cube plus 4 white protons around the outside 4 sides. In this carbon-12 on the right, there's nothing on the top face of the cube and nothing on the bottom face. Now, if we look at nitrogen, it's much like carbon, but it has one more added. Oh, there it is, yeah, nitrogen. So this is the archetypical element with 2 layers in the cube. Whereas iron is the archetypical element when there's 3 layers in the cube. What I mean is each face has a simple stack of armor covering the face. There's 6 faces. So here's nitrogen 14. Now, it has an interesting shape. See how there's 3 protons there radiating out from one point. I propose that that is much like the chemical symbol for N2, nitrogen, that there's 3 bonds. Now, let me put in one of these bonds because this is the geometry that's important. All right, now bonds are very difficult to see, so I'm using steel wire that's extremely thin. That on YouTube probably is vanishingly thin. So if I stick it onto nitrogen here, it'll just disappear from your low quality video here. Live streaming of a piece of wire put onto nitrogen mock-up, and at the end of that it would be the electron, which is so small you can't even see it. But it has 2 space dimensions, and if that's too small to see, I have another wire prepared with a little electron stuck on the end of it. Okay, here's the other one with the little marker, and I can then go to the nitrogen and put it on this one over here so that we can get 3 electrons coming out from these 3 protons. There, so that's a little bit easier probably to see on your video screen where the electron is marked with a little piece of tape coming out. Now, these can only move in 2 dimensions, and 1 dimension is fixed. So it's a spring. If I put an edge on here to the camera, you can see the spring can move in this dimension, but not the other way. That's because it's modeling the 2-dimensional space interaction between a proton in white and the electron at the end of little springs. Now, this also, if you brought this electron too close to the proton, it would get pushed away. But if you dragged it away, it would be pulled in. So much like the way an electron is. It doesn't crash into the proton. It stays in some orbital level at 1 angstrom away from the proton. And then it just balances there. And there's actually a formula I came up with, the atomic radius formula. I'll show you some other time. But let's go back to some of the other texts I was telling you about. Oh yeah, here's the famous text. Now the thing I'm trying to say is that the wave function is a bond, a chemical bond, and this is a flux, and that is the same as an ampere or Weber, or the length of a velocity, or area per second, or lines per second. They're all different types of flux. And that's what a wave function is. Flux squared is energy. And a bond is a flux. And so units of measure are coming back into fashion here. And as I was showing in this little model, there was replenishment as in the harmony of 2 hydrogen atoms. So let me draw a picture of that for you. Replenishment of 2 hydrogen atoms in harmony with each other for H2, the H2 molecule. It'll be a hand-drawn sketch starting out with a blank piece of paper, because that's the way theoretical physics is so often. All right, almost ready to show you the pictures of what I'm going to do here. And I'm going to put a piece of paper up for you to look at here. All right, there's the paper. Now I'm going to bring out the actual pens. All right, so replenishment, hydrogen. Let's see, here's a 1 hydrogen. And it's connected. The electron and proton are connected by 3 dimensions. Okay, so that's real clear. The proton on the left and the 3 dimensions connecting it. They're all orthogonal to each other wherever they meet over here. These are right angles between each dimension as they hit the particle. Now the other one would be going the other direction. All right, so there's the second proton on the right and the electron that's paired with it over there. And what I'm trying to say is that the red one is going this way and the black one is going the other way, these dimensions. Just like gravity relative to the electron. So here's the electron, E minus. And this space, like gravity, is coming into the electron, and a time-like dimension is coming out of the electron. Just like on Earth, for gravity, space is coming into the Earth, and time is growing out of the protons and neutrons on Earth at the speed c. Now these velocities all have the average velocity of the energy of a proton divided by the momentum of free space. So 938 million electron volts divided by P, which is the proton volume over 5 nanoseconds. That tells you the velocity on the average of all 4 dimensions for the proton is speed of light divided by 187. There's the 4th dimension coming out of the proton. Now, as far as the molecule goes of this, you notice that on the spin is counterclockwise here. Counterclockwise. Oh, yes. Now, so, of course, the other one is clockwise on top. But we're going to show bonding between these on the bottom, where they're both going counterclockwise. So, in other words, we're going to have one coming out over here. And one going in over there. And then one that's not directly involved. Let's see, a black one. So we see that the arrow's pointing this way here. See how it lines up? The red and black have the arrow going the same way. And then the one that returns is also spinning counterclockwise. So you see how the red arrow is going right for the bottom atom, and the black arrow is going right on the top atom. And this loop is going around right in the middle here. And this loop I'm going to circle in red, so it's real easy to see. There is the bond between 2 hydrogen atoms into a hydrogen molecule. It's in these 8-dimensional physics accounting system. These are dimensions 5, 6, 7, 8, where 5 is time-like in red. And then in black is the space-like dimensions of the atom, which I call HX, HY, and HZ. So HZ goes to neutron, but HX and HY go from the proton to the electron. So this is the basic sketch. Now, if we go back to the model of Blender, for example, we can see how this would work out in improved graphics. Alright, so as you can see, this Blender is not complete yet. There's still more types of things that I should be doing for this. For example, this electron over here. Let's see, I should be able to just move that around. Yeah, so let me put it back in a better place. There, it's in a better place now. Alright, so anyway, I'm going to be drawing in those circles, like that in the pen, the red pen just a minute ago. I was showing a connection that came out of a proton and went in a loop into the hole in the electron, and that came out of the protrusion here. So this is going to the indentation on the proton. So you get this flow that's going to be going on in this counterclockwise spinning direction. someday. Yeah, when I get around to it. It's going to take time. It's like next week or something. So I may go off the air for a while as I'm laboring strenuously to put in a membrane. I call it a contraspline. And that kind of thing is shown, you know, in my older pictures that I've been showing for 2 years already of the contraspline. And that's on a whole website. Oh yeah, it's a website of impure math. And so I'm going over to something else right now, back to some kinds of words on the screen here. So you saw the replenishment going on, in which the time-like dimension is coming back to replenish the space-like dimensions. And there's a circle, a loop. Even you can call it a bond, but it's not a one-way street. Gravity is not a one-way street. Bonds are not. Time has to come out. And a time-like has to come out of the electron to replenish the space-like from the proton. Now, nitrogen is also something which I have a model of right here. I showed you how it fits together with the a few little electrons. And it's a mechanistic film from an electron. And it's not some kind of quantum magic. It's a quantum mechanistic explanation in which an accounting system is separating out time and space as the basic units. And this is available on my website for impure math. I have the periodic table of units of measure. So in that mock-up I was showing you of the wave functions coming out of a nucleus and things, these lines of protons that you see inside of these nuclei are clues. These are clues to electron motions. Lines of protons. This one, for example, suppose that would be on cerium, for example. I didn't look it up recently, but anyway, since the protons are like this for iron, I have some certainty that lines of protons form commonly in all heavy elements, and that this gives a clue to the motion of electrons. That the electrons were moving around and putting the protons into those positions. During fusion inside of stars, the fusion occurred under the influence of electron motions in those two dimensions, forcing lines to form. And also, in chemistry, the rings of protons make eddy currents, like in iron. And as an example, look at the benzene ring current. Consider that to be a paradigm for what I'm proposing in terms of the itinerant proton currents. So going back now to my final slide, I'm going to be telling you about the animated spins, and the time-like dimension in a molecule is a boundary of spin. A space-like dimension is the other spin boundary. And once these are working in Blender, photons can break out from these membranes. And I propose that a photon is two of them, one time-like, one space-like, that breaks out of a wave function to go away across at the speed c. And that concludes the things I wanted to say for now. So I'm going to be signing off in about 24 seconds.
Hello, it's Alan Folmsby here in my front yard. This is where I discovered the shape of the iron nucleus.